Unit 5B, Lesson 1, Build Functions that Model Relationships. So we're going to review some formulas we've talked about previously throughout the year. Now we're going to apply them directly to just application problems. Here are a few of the common formulas we talked about previously. We have the slope-intercept form for a linear equation, y equals mx plus b, m being the slope, b being the y-intercept. We also have the standard or general forms for a linear equation, ax plus by equal to c. We had this equation if we were talking about adults and children going to some park where the cost of a ticket is a different price. Then we had to set it up in this form. We could use the cover-up method to quickly find the x and the y-intercepts. And then we had equations for calculating the amount of money in an account or something like that based on interest. So if it's compounded annually, we have a equals p times a quantity of 1 plus r raised to the t. P is the principal amount, the original amount. R is the interest rate as a decimal. And then t is the time, normally in years. We have the equation if that interest is compounded multiple times per year. The only thing that changes is we have to divide our rate by the number of times it's compounded a year. For example, if it was compounded quarterly, that would be 4 times per year. Our end value would be 4. Then we also have to multiply the number of years in our exponent by that end value. The last equation is if interest is compounded continuously. We have a equals PERT. We have our principal times that constant of growth, e, 2.718, raised to the r times t power. So these are some of the formulas we're going to be using throughout this lesson. Now to the first example. Jim is a furniture salesman. His weekly pay is $300 plus 3.5% of his total sales for the week. Jim sells x dollars worth of furniture during the week. Write a function p of x, which can be used to determine his pay for the week. Use this function to determine Jim's pay to the nearest cent for a week when his total sales is $8,250. So first we have to determine what type of equation is going to model this. In this case, it's going to be a linear equation in slope-intercept form. We have the y-intercept, which is $300. That's the fixed rate, his fixed base salary. And then he also gets 3.5% of his total sales. 3.5% of means multiply, so multiplied by x. I can see that's going to be a linear equation. So we have an equation p of x equal to, we always want to convert this percent to a decimal, so 0.035, that's the rate, times x, which is the dollars worth of furniture during the week, plus his base fee or salary of $300. So p of x equals 0.035x plus 300. Now we want to use that equation to determine what Jim's pay would be to the nearest cent for a week when his total sales was $8,250. So we simply have to plug $8,250 in for x. So we take 0.035 times 8,250 plus 300, and now we get a total of $588.75. So that would be Jim's profit for that week if he sold $8,250 worth of furniture that given week. Now into the second example. Brooke has a movie rental card worth $175. After she rents the first movie, the card's value is $172.25. After she rents the second movie, it's $169.50, and then after the third, $166.75. Assuming the pattern continues, write an equation to define a of n, the amount of money on the rental card after n rentals. And then Brooke rents a movie every Friday night. How many weeks in a row can she afford to rent a movie using only her rental card? So the first thing we need to do is determine the rate at which this is changing, which represents the value of each rental. So if it started with 175 and then after the first rental is 172.25, the value left on the card, that means that rental was $2.75. If we go through the second rental, we would get the same thing, $2.75. So that must be the cost for each rental, which is a constant rate. This is going to be a linear function. So a of n, the amount left on the card after n rentals, is going to be equal to, we have to have negative 2.75 because that's going away from the card each time, times the number of rentals, plus 175, the amount she started with on the card. So here's an equation that can be used to represent how much money is left on the card after n rentals. So now we want to determine how many weeks in a row can she afford to rent a movie using her rental card only. So we're going to put 0 in for the amount left on the card and now solve for n. So first thing we could do is add 2.75n to the other side and then divide 175 by 2.75. When you do that, you get n equals 63.63 repeating. So now we want to determine how many weeks in a row can she afford to rent a movie. Well, we have to actually round that down to 63 weeks. We can't go up to 64 because she would not have enough money on the card to rent a movie on that 64th week. So 63 weeks, that's how many weeks in a row she can go renting a movie each Friday when the cost of each rental is $2.75. Now to example 3, the country of Benin in West Africa has a population of 9.05 million people. The population is growing at a rate of 3.1% each year. Which function can be used to find the population 7 years from now? So this is slightly different than the first example when we had a rate. In the first example, we had a rate times the amount of sales that they had. We had that word of in there that was indicating multiplication. That was a linear function. Now we have a rate of 3.1% that's growing each year. This is representing an exponential function. So we have to start to recognize the difference in what those rates are meaning in terms of the problem. So since it's just growing at this rate each year, we have to use our basic equation, a equals p times 1 plus r raised to the t. Plugging in our values, we have a equals 9.05, that's the initial amount, the principal amount, times 1 plus, convert our rate into a decimal, 0.031, raised to the t power. The t is 7 years. Now we just plug this into a calculator, we get approximately 11.21 million people. So if this country grows at that rate over the course of the next 7 years, that's what they can predict the population will be of that country, 11.21 million people. And now to the final example. Tony invested $5,000 in a savings account that earns 1.2% interest compounded quarterly. He made no additional deposits or withdrawals. Write an equation to model the amount of money A in the account after T years. Find the amount of money in the account in 6 years. So in this problem, we have to use the equation where it's compounded multiple times in a year because it says quarterly, which is 4 times in a year. So we have the equation a equals p times 1 plus r divided by n raised to the nt power. Our principal is 5,000. Our rate converted to a decimal is 0.012 divided by 4 because it's quarterly raised to the 4t power. So we can use this to model the amount of money in the account after t years. Now we want to determine how much money is in the account in 6 years. So now since we're looking for 6 years, we could take 6 times 4, that's where the 24 comes from. Now we just plug this into a calculator. You get approximately $5,372.70. That's how much money would be in his account if he didn't do anything with it, no deposits or withdrawals in 6 years, if it earns 1.2% interest